Alright, so the Trig Identities, this was 5-9, and in some cases 5-10, depending on when I gave it to you. So we are going to be discovering the trigonomic equations and identities to try to put them in a simpler form so that we actually can solve them algebraically. Considering the equation 2 sine theta cosine theta equals 1/2, we don't have the algebraic skills at this point to solve that. We do know how to solve graphically when we don't know how to solve algebraically. So if I graph 2 cosine x sine x, and what I want to do here is go up to my tools in the upper right hand corner. I know you can't see this very well, so I apologize. You want to change the x-axis step to pi divided by 2. And that's going to make it much easier for us to see where those patterns actually happen. And we've got the bell ringing in the middle of that, so that's lovely. So I'm going to turn this on the side and look at this a little bit closer. So if I look at this graph, this is 2 sine x cosine x. It starts at 0, 0, goes up to 1. I'm actually going to scale this as 1 up here. Goes up to 1, goes back to the midline, down to -1, and back to the midline. And it continues like that. So that's my sketch of it. That pattern is going to continue if I keep going. And keep going this way as well. And then if I also graph a second one, y equals 1/2, and that just gives me that line. That's the solving graphically part that we haven't done for a while. But when I graph both sides of that equation, I'm given these points along here where that happens to work out, and we know those are our actual answers. So we can give some approximations there, but we do want to be able to eventually have, so that's our y equals 1/2. So we have solutions here, 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 and here on the graph that we can see. So between 0 and 2 pi, this is where 2 pi is. We're looking at, so this is 1 pi. If we split that off, we're looking at something along the lines of pi, like 1/10 pi. We're estimating though. We can zoom in further and figure that out, but what we really want to do is be able to find that algebraically. So to that, if we look at the graph of, I'm going to go ahead and take that 1/2 off, 2 cosine x sine x, and I look at that carefully, what I might notice is that looks exactly like a sine graph. Goes up to 1, comes down, except it's a sine graph that has been changed in terms of the period. So if I look at this 2 sine x cosine x and I make a different one, that's my hypothesis that this is actually just the sine of 2x, because I have a frequency of 2. Then as you notice, the orange went over our original one. So as it happens, the simplest form there is sine 2x. So if I have sine 2x, and this is what was tripping people up in when you guys were doing it on your own, so I've got sine 2x equals 1/2, rather than 2 sine theta cosine theta, which I don't know how to solve. I actually do know how to solve this. So I can take the inverse sine of both sides, and I'm not going to use the calculator for this. I could, but I'm not going to get what I want. What I actually want to do is use my unit circle for this. So what I'm looking for in my unit circle, what I have here now, once I take this, is 2x equals the inverse sine of 1/2. And I could put that in the calculator, as I said before, but I'm not going to get exactly what I'm looking for. Because what I really want is to find out where the sine is 1/2, between 0 and 2 pi. So if I look at my unit circle, remember the y value is the sine, so I have a sine of 1/2 at pi over 6, and then I also have a sine of 1/2 at 5 pi over 6. So this can now be two things. This is pi over 6 and 5 pi over 6. So I'm going to have two solutions here, which we noted up here between 0 and 2 pi. Sorry, you can't see where I'm pointing. Between 0 and 2 pi, I had two places where that was true. So 2x equals pi over 6, and 2x equals 5 pi over 6. So if I divide that by 2, dividing by 2 is the same thing as multiplying by 1/2, and that's a little easier to deal with when you're talking about fractions. I'm going to use this for both, so just ignore that. So what I'm left with here is x equals pi over 12. And here, when I do this, this is x equals 5 pi over 12. And those are my two answers. So that's one way that I can use those identities and my inverse functions to figure out those algebraically. So this is the double angle identity for sine. For the sine, this is that the sine of 2x equals 2 sine x, parentheses there, and then cosine x. That's one of the identities I'm going to be working with. So, hang on. Okay. So if I am looking at some other ones, I'm basically trying to figure out my easiest way of rewriting this. So if I write, sorry, back to Desmos. Sorry, this is a very choppy video. You'll just have to forgive me. Okay, so if I do sine x, close my parentheses, divided by tangent x, close my parentheses, what I notice is that this is exactly a cosine function. Starts up, goes down at pi over 2, or goes to the midline at pi over 2, it goes down at pi, back to the midline, and back up. And so between 0 and 2 pi, this is the same thing as the cosine of x, which shouldn't be terribly surprising since we know that the tangent of x is sine over cosine. So that's one of the other identities I'm dealing with. So the next one, I'm not going to graph it. You guys can draw a graph on your own. Just make sure you're labeling things, labeling your axes. So on this one, I'm going to delete that. So I need parentheses 1 plus sine x squared plus cosine squared, nope, not that one, plus cosine squared x. Alright, I'm going to have to turn this one sideways. Stretch it a little bit this way, down that way. There we go. Okay, so we are trying to find, according to the instructions, we're trying to find this with no horizontal shift. So we're not moving it left or right. So one of the things we see this, so we can't shift it horizontally, so if we start at our midline, this is going to be a sine graph. From our midline we go up 2, so that means our amplitude is going to be 2. We are starting at 0 and ending at 2 pi, so there's been no change in frequency. Sorry you can't see me write that. I'm not too on it today. So this is just of x, no frequency change and no horizontal shift. And then it's being moved up 2. Our midline has been moved up to 2, so this is going to be plus 2. So that's another identity. Not necessarily a lot simpler, but a little simpler. So what you guys are going to be doing, I'll do one more with you here. So this 1 plus sine theta squared plus cosine squared theta is now, as we know, 2 sine x plus 2. So that equals 4 based on this equation. So solving that algebraically, subtract 2 from both sides. So we've got 2 sine x equals 2. Divide by 2. So we've got sine x equals 1. So now I'm looking at my inverse sine. And can I write this backwards? So don't mind me. Inverse sine of that. So I need to know where my sine equals 1. And the only place that that happens on my unit circle is at pi over 2. So then x equals pi over 2. And if we look at that graph, here we are. I cannot see very well, so I apologize. So here is pi right here. So that makes this pi over 2. So at pi over 2, y equals 4, which is what we're going for. So that's our only answer on that one. So on the worksheet that is for the rest of it, you're doing the same thing with several different types of equations, finding those identities, and then on the backside using those identities to solve and find those more difficult problems. So good luck with that. Hopefully it helps over the next couple days so you guys can get that in. Have a good one.